So we're going to start with the definitions for A2 chemistry, and we did enthalpy of combustion, enthalpy of formation, which was AS. Okay, I'll just quickly do, just for the sake of completion. I'll just quickly do enthalpy change of neutralization, just very quickly. So delta HN, that was also AS, standard enthalpy change of neutralization, and that was and then there's going to be A2 definitions. Okay, so enthalpy change of neutralization was in the briefest possible way was that you have an acid-based reaction, and a certain amount of energy is going to be produced when an acid and a base react, and when they react, they're going to produce salt and water molecule. I just saw you up, TK. So enthalpy change of neutralization was that you have an acid-based reaction, salt and water gets produced. If 1 mole of water gets produced, then the energy change is known as enthalpy change of neutralization. That's known as enthalpy change of neutralization, and it was always exothermic. And for any strong acid or strong base, the value was kind of the same. It was close to minus 57 kilojoules per mole. And if it was a weak acid or a weak base, then the value was then the value was slightly less exothermic. So it was probably around minus 52 or minus 53, something like that, kilojoules per mole. So slightly less exothermic. So every time it had kind of the same value. Why? Because every time the reaction is kind of the same. It doesn't really matter what the acid is, because the acid produces H plus ions. So whether the ions come from HCl or whether they come from nitric acid or sulfuric acid, it's kind of the same thing. TK, and base ka bhi wahi tha, it doesn't really matter what the base is. The base brings in the OH ions. So every time you have the same reaction, since you have the same reaction, the enthalpy change or the energy change is kind of the same. So that was standard enthalpy change of neutralization. तो अब ना इसके बाद after this thing we will now do A2 definitions. So we're going to move to A2 chemical energetics. Okay, AS revision we missed out on. The only thing we missed out on was Q is equal to MC delta T. I'm going to cover that right at the end. So A2 chemical energetics, and initially we'll cover the definition. The first one, now we have to write proper definitions because these were not, you've not covered this in AS. So the first one, number one, that is standard enthalpy change of atomization. So it's usually written as delta H atomization with a knot on top that represents standard conditions. So the first definition. Now what? So now the definition is that you have an element in standard state, which is the state at room conditions, 25 degrees centigrade, and 1 atmosphere pressure. And using that standard state, you take that element and you create 1 mole of gaseous atoms. Now, the only way you can create these 1 mole of gaseous atoms is that you're going to break bonds. I mean, that's how you're going to get atoms. So if you're breaking bonds, it's always endothermic. So it's always endothermic. So for example, if I have this reaction where I have the element Cl2, which is gas in its standard state, and this Cl2 turns into 1 mole of Cl gaseous atoms, 1 mole of them. Now this has to be 1 mole. So I'm going to take it as, if I need to balance this, I'm going to take it as half moles of Cl2. So I have to keep, I mean, I'll always have to produce 1 mole of gaseous atoms. So this is enthalpy change of atomization of Cl. So if I have enthalpy change of atomization of, let's say, carbon. So carbon in its elemental form under standard condition is carbon solid. It's actually graphite. I mean, normal carbon is graphite. You don't take diamond as normal carbon. So this carbon solid will turn into, you're going to break bonds. ठीक है, वो graphite में जितने भी bonds हैं, you're going to break them up. And what you're going to get is 1 mole of carbon gaseous atoms. So the enthalpy change of this reaction is going to be known as enthalpy change of atomization of carbon. So basically, the proper definition for this thing is, if they ask you to write the proper definition, that's it's the energy that is needed when what happens when 1 mole of gaseous atoms are formed. So 1 mole of gaseous atoms are formed from its element in its standard state. And since you're talking about standard conditions, so it's measured under ठीक है, ये clear है? Ahmed, Saad, Hasina, is this clear?
Yes, sir.
अच्छा, so
Yes.
ठीक है, so that's the proper definition of enthalpy change of atomization. But always remember, the key is that it's 1 mole of gaseous atoms, ठीक है, that is formed. So either जो moles है ना इस side पे, you just have to balance it accordingly. For example, over here I had to make it half Cl2 because there was 1 Cl atoms, but over here I didn't have to do that because it was already balanced. So the other thing is that atomization can sometimes be found from bond energy. So not always, but sometimes it can be found from bond energy. So for example, this equation, this one over here, the enthalpy change of atomization of Cl is basically equal to, how many bonds did you break over here? You broke a Cl-Cl bond and you broke half moles of them. So it's basically equal to half the bond energy of the Cl-Cl bond. So in this case, if you look at the equation carefully, you're breaking exactly half moles of Cl2 bonds. There's a bond between them. You break that and you get Cl gaseous atoms. Is this clear? How to find enthalpy of atomization most of the time? Is that clear?
Yes, sir.
Yes, sir.
Achha, but can I use bond energy for this one? If I've got graphite and I want to form 1 mole of gaseous carbon atoms, will enthalpy of atomization of carbon be, can I use bond energies in this case? जैसा पहले वाले में किया था, I did use bond energies, but over here, can I use bond energies? Is that possible?
I don't think so, sir, because it's not a gaseous molecule.
ठीक है, so ठीक है, that's fine. Now in this case, अच्छा, now in this specific case, you can't use bond energies because so you can't use bond energies because bond energies are specifically defined for gaseous molecules. It's not defined for solids. Okay, so remember this thing about bond energies. So over here I can't use bond energies to figure this out. I say it's only defined for gaseous molecules. So you have to be careful. वो तार अंदर लगा देना. So just hold on 1 second. Let me put the charger. अच्छा. So we're done with enthalpy factorization. Just be careful with the bond energies. So we're going to skip to the second one. To get the second definition. That's one A2 definition. Clear enough? Is Hasina, is this clear? Enthalpy factorization.
Yes, sir.
So we're going to move to
Yes.
so we're going to move to the next one, which is I'm going to do lattice energy at the end. Let's do electron affinity first. ठीक है, lattice energy is the big one. ठीक है, so there's a lot going on with lattice energy in this chapter. तो पहले ना ये छोटी वाली कर लें, electron affinity. So now with electron affinity, the thing is that it's what is electron affinity? It's kind of the opposite. It's kind of the opposite of ionization energy. In ionization energy, you actually removed electrons. Over here, you add electrons. So it's exactly the opposite. It's endo or exo. It could be both. So it's the energy that is released or absorbed when what happens? When 1 mole of gaseous atoms they end up gaining 1 mole of electrons. To form 1 mole of gaseous minus 1 ions. So exactly the opposite. There you were removing electrons, here you're adding electrons. So I've got a Cl atom and it's 1 mole of gaseous atoms and it ends up gaining 1 electron and it will form Cl minus 1 gaseous ions. So and this is known as the electron affinity of Cl. Or you can also write it as the first electron affinity of Cl. I said now electron affinities, we don't really talk about electron affinities the way we talk about ionization energies, because for Cl, there's only going to be one electron affinity. Cl normally just gains one electron. That's about it. It doesn't gain more than one electron. Ionization energies mein hota tha ke you just kept on removing electrons from an atom. But when you're adding electrons, you would just add the appropriate number of electrons. You don't just keep on adding electrons. So for example, oxygen over here, how many electron affinities would oxygen have? Normally, how many electrons does it gain?
2.
ठीक है, so 2 होगा, ठीक है. It normally just gains 2 electrons. That's 1. It's going to become oxygen minus 1. That's gaseous. This is the electron affinity of oxygen atoms. And then there's going to be a second one, which is once it's oxygen minus 1, gaseous, it's going to gain another electron. And when it does that, it will become oxygen minus 2 and it will be gaseous. And that's your second electron affinity, or you can write it as, I mean, the way it's normally written is electron affinity of oxygen minus 1, because it's oxygen minus 1 that's gaining electrons. तो ये उसकी notation है, ठीक है, but kind of the same as or opposite as ionization energy. अच्छा, अब इससे आगे ये कि about electron affinities, sometimes it would be written together as well. So for example, you might see this thing. यहाँ पे ना there's a gaseous N atom, and it's gaining 3 electrons, and when it gains those 3 electrons, so in that case it becomes N minus 3 gaseous. Now this one is basically 3 electron affinities. This is the electron affinity of तीनों combined है, ठीक है, in this case. Just 1 second. So it's in this case it's electron affinity of N plus electron affinity of N minus 1, and then the third one, which is electron affinity of N minus 2. Okay, so it's all 3 combined. That's the notation that's going to be frequently used. So that's this one. Acha, ab iska, can you tell me whether it's going to be endo or exo? What do you think? Is it endothermic or exothermic? क्या होगा? Imagine Cl gaining electrons. Does it need energy or does it not need energy, or is it going to release energy? What's going to happen? Any idea?
Release.
Is it exo?
Yes, remember that it's exothermic because why is it exothermic? Because Cl is highly electronegative. You already know that Cl के पास ना protons, it's got a lot of protons, 17 protons, and elements on the right side of the periodic table, they tend to gain electrons, and because their nucleus is going to attract electrons, so they're going to do all the work. All the work is going to be done by the atom, not by you. No energy is needed from outside. You don't have to make the electron energetic. You don't have to give it energy, because all the energy would come from Cl pulling the electron on its own, its nucleus attracting the electron. So it's going to be exothermic. All the work done will be by the atom itself. So this one is exothermic. And the first one is always exothermic. Okay, so remember this, that the first electron affinity of any element is always exothermic. You get the nucleus attracts the electrons, does all the work. But then when it comes to the second and the third and the fourth and the fifth, the rest are all endothermic. So apart from the first, the rest are all They're all endothermic. तो इस इस पे फोकस करना कि let's look at oxygen. The first one is exothermic. ठीक है, oxygen is I mean this one over here. Oxygen is one of the most electronegative elements. Pulls the electron on its own, does all the work. TK gains that electron, becomes -1. So all the work is done by the atom. Exothermic. Second one, ठीक है, उसके बाद मैंने कहा था the rest are all endothermic. So this one, ये वाली जो है ना, this one is now endothermic, right? So can anyone guess why it's endothermic, the second one or the third one? Okay, what happens? Why does it flip? What happens after the first one? Okay, with that it becomes endothermic. Any idea? Saad, Ahmed, Arun, Fahad, any idea? Any idea? Just common sense. Why is this one endothermic? Sina, any idea?
No, sir.
Achha, so one second. Take a minute. Recover just a second. Achha, so this one. Achha, I'll tell you just I mean the second one, why does it become difficult to gain electrons? Because now it's a negative ion. Negative ions don't attract negative electrons. Negative repels negative. So it becomes extremely hard for the ion to actually gain electrons. So the only possible way that the repulsion can be overcome, you can overcome the repulsion is that the electron is made energetic. And so you would have to give the electron energy, which is why it's endothermic. So gaining the first one is there's no repulsion. It's a neutral atom and there's an electron. There's no repulsion. The nucleus is going to attract the electron. Second one, this is a negative ion now, and the nucleus. So the negative ion is not really attracting that electron. There's going to be repulsion. Okay. So is this part clear that why the rest are all endothermic? Is this clear? Yes or no?
Yes.
Yes.
Yes, sir.
So negative ions repel electrons. So the idea is that अगर ये nitrogen है ना, gaining the first electron is easy. Gaining the second electron becomes more difficult. Gaining the third electron becomes even more difficult. So subsequently, it becomes harder and harder to actually gain electrons. So negative ions repel electrons, which makes it very endothermic. So that's the idea. Now, and that's it. That's pretty much what electron affinity is. You have to study a simple trend in electron affinities in group 17. So trend in electron affinity. And this trend pretty much applies to group 16 and 15 as well. But let's focus on group 17 at the moment. So the trend is, I need a, so the trend is that you've got, I need an inverted graph, just a second. So it's all अच्छा just 1 second charge it मैं set कर लूँगा